Hello, everyone. I wanted to take a few minutes and review with you the basics of factoring. So let's start by talking about factoring out the GCF. Factor out the GCF. So that means greatest common factor. So let's look at an example. If I have 18x cubed minus 27x squared. So we're looking for the largest number that goes into 18 and 27 evenly, and that would be 9. And then x cubed and x squared, the largest number of x's that go into both of those would have to be the smallest exponent, which is x squared. So the GCF of two variables is always the smallest exponent. So what we have found is the GCF. Now to factor, we're going to open a parenthesis and do the distributive property backwards. In other words, I want to figure out what do I need here so that when I multiply by 9, I get 18. So that would need to be a 2. And then what do I need to multiply by x squared? That would give us the x cubed. And that would need to be 1 power of x, because when you multiply variables, you add the exponents. So then we move on to the next term. 9 times -3 would give us -27. We don't need to multiply by any more x's because I already have the x squared that I'm multiplying by here. So that would be our final factorization. The next type of factoring is grouping. So to factor by grouping, if I have x cubed plus 4x squared plus 3x plus 12. So what we need to do is separate these into two pairs, and we're going to factor each pair. So factor each pair. So if I factor out the GCF here, that would be x squared, and that would give us x plus 4. Bring down this middle sign, which is a plus, and then from the second pair, I can factor out a 3, and that leaves x plus 4. Now notice that gives us x plus 4 in both of these places. So what I have is some quantity plus some quantity, and both of those quantities have the common factor x plus 4. So what we're going to do now is factor out the GCF that's in parentheses. So we factor that out. That leaves x plus 4. If I pull that out, that leaves x squared plus 3. So that is our factorization. All right, so that's grouping. Let's do one more example. So x cubed plus 5x squared minus 2x minus 10. So you might want to pause and try this one on your own. And then when we begin, we separate these into two pairs. Factor each pair. So again, we're going to factor out the x squared, and that leaves x plus 5. Pull down the minus, and then factor out a 2. Now be aware that this is actually a -2 we factored out. So when we multiply, a -2 times positive x would give us a -2x, and a -2 times positive 5 would give us the -10. So again, notice that we have our GCF in both places here. So we factored out by stating it one time, and then that leaves x squared minus 2. Now, I often get questions here because they don't understand why we only write x plus 5 twice. I'm sorry, why we only write it once. So let me give you an example that's sort of related to that. Let's say I have x squared y minus 2y, and I asked you to factor that. So again, we're just looking at this problem. the GCF here is a y, so we write that down. That's our GCF. And then we open a parenthesis, and we would need to multiply by x squared minus 2. So again, notice that this is my GCF. I factored out here. Just like here, I had the GCF, and I factored it out. So the only difference is, in our case, instead of a y, we have x plus 5. So whatever you're pulling out as that GCF, you only write it one time. That's part of the definition of factoring, that you're expressing this multiplication. So hopefully that helped a little bit. All right, so factoring out the GCF, factoring by grouping, and next we need to factor trinomials. Now there are many different methods for factoring trinomials. So I'm going to show you the method that I have decided after many years has worked the best for my students. If you know another way, feel free to use it. You know, basically it's whatever works for you. Let's take an example. 8x squared minus 10x minus 3. Okay, so again, here is how I teach it. I'm going to pick a different color here. All right, so what I want to do is take the first term and the last term. So in other words, I'm going to take the coefficient of the first term, which is an 8, and the constant, which is a 3, and multiply those together, disregarding the signs. So we're just going to take that leading coefficient and the last term and multiply them together. Now, we're going to list all factor pairs. List all the factor pairs. What does that mean? What times what would give us 24? So of course, 1 times 24. We could have 2 times 12, 3 times 8, 4 times 6, and then that's it. We would run out after that point. I think I got them all. Okay, now we want to pick the pair of these that combines by adding or subtracting to give us the middle term. So we want the pair that combines to give us the middle term, which in this case is 10. So looking at our pairs, I see two possibilities. 2 and 12 could give you 10 by subtracting, and 4 and 6 could give you 10 by adding. So we need to figure out which one is the right answer. The first thing we need to do is think about the signs. So in other words, for 2 and 12 to give you a negative 10, the 12 needs to be negative and the 2 needs to be positive. Everybody understand that? A positive 2 and a negative 12 gives us a negative 10. So what we're going to do is replace the middle term with that combination. So we're going to replace negative 10x with positive 2x minus 12x minus 3. All right, so we rewrite that middle term with our new combination. So just for emphasis there, and because I like using this highlighter, I'm rewriting negative 10x as positive 2x minus 12x, but it's the same value, right? We've just expressed it differently. Okay, and now we're going to factor by grouping. Factor by grouping. So I'll write that down. Now factor by grouping, the way we just learned. So first pair, second pair. GCF here is 2x, and that leaves 4x plus 1. Bring down the sign, and then let's factor out a 3, and that leaves 4x plus 1. So our GCF is 4x plus 1, and that leaves 2x minus 3. Now we can always FOIL to check, but this is our answer. So this was the right one. Now, I'm not going to take time to do this right now, but if you pick this one, what would happen is it's impossible to factor. You can't factor it by grouping. So you would have to be in there trying it to see. In fact, you might want to do that as an exercise. All right, but that's the method that I use to factor trinomials. So let's do another one. All right, so let's take x squared plus 3x minus 18. Okay, so for this one, our leading coefficient is a 1. So I'm multiplying 1 times 18. 1 times 18. Of course, that's 18. List our factor pairs. So 1 and 18, 2 and 9, 3 and 6. And that's it. So which of these pairs can add or subtract to give us the middle term of 3? Only one choice this time, the 3 and the 6. And we would need to subtract. So it would need to be a positive 6 minus 3 to give us that middle term. So we're going to replace this middle term with minus 3x plus 6x. And then factor by grouping. So I've got this pair and this pair. Factor out an x, that leaves x minus 3. Bring down the plus, factor out a 6, and that leaves x minus 3. Now, what do these have in common? X minus 3, and that leaves x plus 6. And that's our answer. All right. Next example, 8x squared plus 33x plus 4. All right, so we've got 8 times 4. 8 times 4 is 32. So my factor pairs, 1 and 32, 2 and 16, 4 and 8. I think that might be, no, yep, I think that's it. But I see my answer, the one I need. To get to 33, I need 1 and 32. And they both need to be positive. So rewrite this middle term as positive 1x plus 32x. Now, usually in class, someone asks at this point, what if I wrote them in the opposite order from you? It will still work. It will give you the same answer. All right, so you rewrite the middle term, factor by grouping. So for 8 and 1, all I can factor out here is an x, and that leaves 8x plus 1 plus 4 in common here, and that leaves 8x plus 1. So from both of these, the GCF is 8x plus 1, and that leaves x plus 4. So that is my factored answer. All right, so that's how I factor trinomials. The next thing we need to look at is factor binomials, which involves the use of patterns. So for example, I have the difference of squares and the difference of squares basically means you have something squared minus something squared that will always factor as the sum of those bases times the difference of the bases. So for example, if I want to factor x squared minus 16, you need to recognize that is something squared minus something squared. And we can show that by putting it into this pattern or this formula. We see that the x would be in this box And then what number squared would give you 16? That would be a 4. So we put that in the box. Now the reason we do this is so that we know how to fill it into this pattern. So when we factor it now, it's sum of the bases times the difference of the bases. So it's what is inside that box is what we put into our answer. So in other words, it's x plus 4 times x minus 4. So that's going to be our answer. So basically, it's the adding the square roots and then subtracting the square roots. So let's try a little bit longer problem. Let's say 81a squared minus 49. So again, we want to make sure it fits this pattern. We know there has to be an a in here. And then what is the square root of 81? That would be 9. And the square root of 49 is 7. So that tells us then that we need to take 9a plus 7 times 9a minus 7. So that's our answer. Now you don't have to show the boxes and triangles, but it's just helpful at the beginning to help you see that pattern. So that's the difference of squares. Now you need to know that the sum of squares is not factorable. Sum of squares is prime. That means it cannot be factored. What do I mean by sum of squares? If I have x squared plus 9, for instance, that cannot be factored. A lot of people believe that that would be x plus 3 times x plus 3. But if you FOIL that out, you actually get this, which is not equal. So anytime you are adding two perfect squares, it's not factorable. But the next thing we have that is factorable is the difference of cubes. Now this one's a little bit longer. So we have something cubed minus something cubed. We start by taking the difference of their bases, and then we square the first base and add the two bases multiplied together, and then we add the second base squared. So let's take a look at how we would apply this. Suppose I have 8x cubed minus 27. First step is to see if we can rewrite this in that form. In other words, can we rewrite this as something cubed minus something cubed? Well, the second one is the easiest. What is the cube root of 27? And that would be 3. So we can rewrite 27 as 3 cubed. And it's very important that you identify what goes in this box. What is the base? What is the cube root of 27? And for the first one, of course, we need to have an x in there. And the cube root of 8 is 2. So now this formula, which might have looked complicated when you first looked at it, is just a matter of making these substitutions. All right, so everywhere there's a square, everywhere we have our square box, we are going to put in 2x. Again, me with our highlighter. That's my favorite part of this technology. See, I spoke too soon. There we go. Okay, so we're going to put a 2x everywhere there's a square box, and a 3 everywhere there's a triangle box. So put a 3, 3, 3. Now to clean this up, we get rid of our boxes. We just say 2x minus 3. Now this part's a little tricky because this says to square everything in the box. So we have to square the 2, which gives us a 4, and also square the x. Plus 2x times 3 is 6x, and 3 squared is 9. A lot of work, but there's our result. So you need to recognize if you're asked to factor something, that it matches this model or this format, so we know to try it. In other words, suppose I asked you to factor a cubed minus 4. Well, you can't just start plugging that into our formula, because you would need to recognize that it cannot be written in this format. In other words, the a cubed, that works, but there's no number cubed that gives you 4. So we would not be able to do this. In fact, that one would be prime. Okay, let's try the sum of cubes now. So you'll remember that the sum of squares was prime, but we do have a formula or a pattern that lets us factor the sum of cubes. So you can scroll back up when you get a chance and compare those formulas. They're just different by a couple of signs. You just have to be careful. All right, so let's say we have 64x cubed plus 125. And the directions will say factor. So the first thing you have to do is make sure that this is a sum of cubes. Make sure it can be written in this format. So what cubed will give you 64? Well, that's going to be a 4. And then we need the x in there. And the cube root of 125 is 5. So again, using our boxes is just sort of a good way to make sure we get everything plugged into the right place. So 4x plus 5, and then forgot my square, my formula. 4x everywhere there's a box, 5 everywhere there's a triangle. And then we clean up by removing our boxes. So 4x plus 5. Remember, this tells us to square everything in the box. So 4 squared is 16, x squared, 4x times 5 is 20x, plus 5 squared is 25. So that is our result. So I know I went through those fairly quickly to give you an overview, but you can, of course, go back and review as you need to, and let me know if you have further questions, and I will be glad to help. So I'll see you in class.